It's a new day and the coils still look absolutely perfect. I'm skipping some steps, but I welded that onto there. It's not perfect, but it's very functional. I blocked off that block off, and then I also welded this bottom shut on that side because we no longer have a pressure regulator inside the engine. Gutted the inside of this whole thing so it's all empty on the inside. I need a third connector like right there off the edge slightly, so it doesn't interfere with the AN fitting here or the sensor here spinning, so all three can work independently. I'm going to drill a slightly smaller hole offset inside the block, and then I'll weld it and connect it to the block. So I can't go to this pinnacle right here because there's a stud right under there, so I'll bore into the stud's hole, and okay, it's going to leak everywhere. Everything's all cooled down, cleaned out. My mess of a table here, but this passed my little pressure test, so we can have both of these sensors vertical. This one goes here, and the pressure goes here, and so now we have the oil inlet here. These are both blocked off because we don't have an internal regulator. This whole inside is all milled out, and then I welded that back shut, so there's a big pool of it, so the temperature should actually be more accurate now. Pressure, of course, is just pressure. So those two things are ready to go. What we're going to do now is take the dash out. Reorganized all the power lines so that way I can actually unbolt the two bolts for the dash, take off the shifter, and then this whole thing comes out and all the wiring is exposed underneath because, again, this is test versions of the wire and this is the harness we're going to use. But I'm not going to cut this any shorter. I would actually, when we go to do like a mil-spec version of the harness, we'll end up using some of this but not all of it. So this right here is the power, both power and ground, but basically it's just a circuit for each of the coils. We're going to take those and crimp those to these. Again, this is version 1. Version 2 is actually going to get proper finished full setup. We'll keep all these jacketed things the full length and then just coil up the extra just in case we need to move these little FT spark units. I don't think we're going to need this because this is like a CAN bus setup for connecting to the fuel tech itself. The ECU, which we don't use, we're using Adaptronic. So that Adaptronic requires this end. The 4 gray lines will go to the Adaptronic for one unit and the 4 gray will go to the other unit. This is our power. So really power, 4 gray lines, yellow line gets grounded for 600 millijoules, and that should be essentially all that's necessary to make these things run. I want to show you guys what is necessary to run this. These are my 10s. So you can see that last 2 digits, 10, pretty straightforward there as well. These are the spark plugs I run on my secondaries or my trailing plugs. They're colder, so the coolant absorbs more of the temperature from the electrode, and you can see it's a beefier spark plug compared to like a 9 or lower, even 5, 7. You can see inside of there is the white ceramic. It is kind of a little hill, a little mountain inside of there. There is air between that and part of this threaded piece here. That air is an insulator, of course. That's going to increase the temperature compared to something that, say, was filled up all the way to the top with ceramic. Even though ceramic is a phenomenal insulator, let's take a look at something more aggressive. I'm not sponsored by NGK, but there are a couple guys in the engineering department that are huge supporters of the channel. And oh my God, Jason in particular, the dude deserves a raise. He is very aware of what this car needs. And this is, you see that 115, that's actually 11.5. This is essentially, as far as I know, available from NGK, the coldest plug that they make. And you'll see what that means in a second. The interesting thing is if you were to plug these in to your car, it might fire up, but it will be so cold, it'll basically be almost the temperature of your coolant that the fuels and all the oils and stuff like that will actually just corrode the tip of this. So from first glance, they're very similar. And it is interesting to note these are 7420s and these are 6725s. I don't know what the model difference is. Somebody might know a little bit more about that, but it's the heat, the temperature we want to do. So this is, again, is the 11.5, and look at that. That ceramic goes right to the edge, all the way up to the end of the threads, really. That is how much that thing is filled in. There's no air to insulate it. So when you compare that, aw, that's a cute couple. That's a 10, and that's a cold plug. This is a true race plug, 11.5. You really need something insane, a lot of energy to combat how cold this plug is. For those of you that are wondering, I do run these in my trailing plugs currently. I'll run 9s leading, 10s trailing. That's actually a recommendation from Elliot from Turbalone, and that's been phenomenal. It's phenomenal for the street and for tons of power using the IGN 1A plug coil setup. This might be what people are more familiar with, the BUR9 or BUR6, which is really a hot plug. And it looks a little different on the bottom, but the 6 has so much air inside of that cross shape or that plus shape. The electrode's in the center, but then well inside of there, there's tons of air. The 9 is better. It's hard to compare these to the race plugs, but they are in fact distinct. We have to take out the steering wheel to get to the dash. One more 10 and this all just pops right out. I used to have tons of shit zip tied to it, you know, when we were first testing it. Okay. 3 bolts and now you can get to everything in the drivetrain. Jason just found a perfect piece of scrap steel. Yeah, so we're gonna lop off probably right there so we have that nice profile around it. We'll lop it square and then we'll figure out how high we need to mount this inside of the passenger compartment behind the dash. You've seen this machine kind of throughout this video a little bit, but I've not really explained what it is. This is a mill. It's a Bridgeport clone. So if you're looking at Bridgeport, knee mill, maybe even end mill, that's what this is. When you say, hey, I have a CNC machine, you really mean you have a CNC mill. It's a machine that uses computer network commands or whatever CNC stands for to do what I'm doing by hand spinning this back and forth. There's a thing called a draw bar up here, and that's what you'll see me wrenching on that allows you to swap this part out. Right now we're using just it's like a drill press. It's a badass drill press. But when I'm cutting heavily, you use something meant for it, and that gets sucked up into there and held into place, so that way it doesn't wobble as much as like a drill press might wobble. It's still pretty damn strong. I was using it briefly, but you can't beat that. I would never ever want to use a drill press again, because just look at the difference. This thing's 3 horsepower, this is like 1. And all the bearings and no slop. We're gonna get this set up to drill each of these holes, so we'll skip through the rest of the process, but we're gonna drill a hole, use the digital readout using Fuel Tech's little diagram, and we don't even have to look at it past that. Make sure it's square. To finish this off just right, I am not this person, but Isaiah is. So watch this. Well, that one's actually pretty good, but you just like, there. We'll take this thing off. Let's see how good I was at reading instructions. So that little tool made it so that way, see how nothing's catching on this side? That's really, really nice. Now this side, not so much.
Pretty
close,
spot
yeah.
the plug on, actually.
Yeah, that's awesome. The guys wanted me to make this fancy. We're going to use the plasma table to cut some names in there. If you were to take the Fuel Tech units off, you'd see this fanciness. Somewhere in there. I don't want it too low because I don't want it to get in the way of the car. There'll probably be something like that. Around that. Tack this in, but I need to control the pedal somehow. Well, what better place than to have an actual gas pedal as a gas pedal? It's like a simulator almost. So we're just gonna move this little thing called a fuel regulator out of the way. But if this melts, we know that we get too hot.
Go.
It's become a very common occurrence to see freight truck after freight truck. That is the most amount of crap that you can fit on one pallet. That's actually really impressive. This is the first time anybody has ordered any of these parts for a Corvette C8, so I guarantee this is the first time of anybody unboxing them. Well, the night was a wild one. If you consider wiring really wild and crazy, then my night was pretty damn wild. It was something where I turned off my phone, I stayed alone. This core is what runs the car. It's hard to believe it, but this is what peak performance looks like. And this is what's made 1,000 horsepower. This is gonna make even more. I cleaned up the core of the power. This thing right here is my PDM, as you guys remember, it was even sitting on the engine stand. This is one of the very first parts I've ever had. All of these are power lines, you know, controlled by this unit, telling each of these things when to take power, when to turn it off, all that sort of stuff. There used to be tons of things spiraling out from here that was unregulated power, and that was all test stuff. Well, I cleaned all that up as well. I actually have my hardcore power coming in. It goes to this relay, which is a 75 amp relay, and then that relay comes back all the way up here through all these little red wires and powers these two units. Again, all the heavy power stuff is gonna stay away from all of the data stuff. This is just sitting up here at the moment, but all the data stuff is gonna stay down here and then go over to the engine. So that way all the electromagnetic frequencies don't interfere. These, though, are the Mac Daddy of electromagnetic interference. These are the actual coil wires. So these will plug into the, I would consider them dumb coils on the other end of the engine, business end. Anything sitting within about 4 inches of these will be affected by EMF signals. You don't want that, especially if it's like a crank angle sensor or something like that. You don't want that at all. I'm gonna go ahead and set up all the trailing ones, all the leading ones, terminate them in the end, and then once all the coils are plugged into this, she's ready to fire. There's one other end to this equation. These are the coil signal lines, and I designed the Adaptronics wiring harness to just be able to plug into those and swap ignition systems as we want. Have all these go into the other end of this connector, and boom, those are the 8 signal wires for all of your spark plugs. This is another one of those things where a lot of people cringe because they think I don't know what I'm doing, and they're generally right. But in this case, this is just more ugly than bad. These are little coil adapters that are sent with the MSD coils, and I'm gonna use them. These have adhesive inside of all of these heat shrink tubes, so not only are you crimping it, but it's not gonna pull out. This makes it a lot easier to test the system without testing the system and potentially damaging the car. I purposely designed this in a way so that way 4 of these have shorter ground leads and 4 of these have longer, because these wires are actually labeled coil A, B, C, and D, and that will be rotor 1, 2, 3, and 4, but there's 2 sets of those. To make that a little bit easier with labeling and not having to get out the label printer, this ground line is gonna go down to the hole on the rotor housing. The longer ones are meant for the coils up here. So I have a nice little quick service loop here. Again, I'm not exactly sure. Even on the test version, I'm not sure where I want these to go. But they're gonna end up having a nice little loop here. I'm gonna get this wired roughly the correct length. These already have a little bit of a length on them. Go like that. And then these wires will go, there's only 2 in here. They'll go inside of there. So I'm gonna cut it right at that halfway point. Here you guys are gonna see the very first cut. Even then I'll still give it a smidgen in the other direction. There we are. I think this actually does have, yeah, it does have a shield on it. So you see those wires? Those are obviously not the core wires. That's a shield. And then there's our good wires. We'll trim all this shit off. We're not interested in keeping the shielded jacket on here because it's already grounded on one side. You don't want to double ground it and create another ground path that goes around a wire. So we're gonna just take it to the side and then continue to clean it up. Trim this up like Barbie hair. I never had dolls as a kid, so I'm just gonna trim the hair on this thing. That's a big lie. I had Barbies. This back off. I'm gonna keep the polarity the same on every single one. That pin A, or pin 1 is ground, and pin 2 is power. Well, there is clean setup right there. It's not the prettiest. Now trimmed each of these to the lengths I wanted. And so we've got dead cables we can take out. I'm gonna undo this zip tie now that we got the exact lengths needed. The world's thickest zip tie. And then now I can do this like a civilized human, not hunched over the side of the car. If you look at the side of the wire, it's already labeled coil B. We know it's rotor 2. And if it's got the longer one, it's rotor 2 leading. Done. Can't mix those up. Now we've got all 4 of these all set up. We'll go ahead and heat shrink those back down. It's time for the trailing plugs. As much as I want to just put them in one big coil, that doesn't actually make sense to do that. So I'll split them back up into long ones and short ones. So long ones go on the top, and then of course the short ones go to the bottom. There's a good first version. It's not like this is like an FD where everybody's done this. Oh, hey, you know, it's easy just to mount this bracket. Nobody's done this before, so I have to kind of come up with some of this as I go. A, apple. B, bravo. D, that's for something else. C, Charlie, I'll be appropriate. And then D, delta.
Kids appreciate it.
That's right. This is why I had to do all that work on the